All right, don't kick over the camera. Yeah.
I'm sitting in the back, I don't see what's going on. Does anybody see me? Oh, that's sexy. Sorry,
Happy birthday to you. Happy birthday, dear Shirley. Happy birthday to you.
Awesome. In addition to birthdays, anything else you want to talk about? Coronavirus? Nothing to say about coronavirus. Just avoid it. All right. Where'd you get your haircut? So I'm laughing when you say that because nobody's asked me about my haircuts yet this semester. So what I do is whenever my hair gets too long, I have some clippers under the sink in the bathroom, and I just so I used to, when I was in school, I used to do it just because I was poor. Now I do it because I'm lazy. I don't want to spend an hour and a half going to the barber and doing it all. So it doesn't look as good, but I try. Like I actually took like way too much off the back. It looks dumb, but it's all right. I noticed there was this big old triangle in the back of my head yesterday. I'm like, honey, can you come in and even this off for me? Anyway, I don't like wasting time. So, anyways. All right, so we have some subnetting stuff to get through. Yes. All right, I'm hoping we can get through as much as possible. What's up? Oh, you're catching a marker? All right. Okay, so real quick, these were the slides that we went over last time. You're supposed to be able to know everything about an address as a learning objective. You're supposed to be able to subdivide a network given some notation like this. We talked about how you might organize your home networks. I mentioned that there are two parts in any address. There's a part that represents the network itself, so this might be the name of the street, like Walnut Street or Apple Street, and then there's the other part, which is the individual host address, the location within that network area. And so there's a couple different ways that we can represent that, but it's the same idea. Street name, and then host address, or equivalent of house number. So I talked about different contexts where that might happen. We talked about this idea of the line that's somewhere in there. It cuts off, and everything to the left is the network address or the street name, and everything to the right is the equivalent of the house number or an assignable IP address. Talked about why we would want to subdivide networks, something that is possible. Oh, okay. And so then we got to here. And I'm going to go ahead and just answer these questions real quick because I'm going to give you the same problem one more time. Dramatic black pause. Okay, so given this address here, how many bits are available for you to manipulate? You already know this. 8. In this case, there will be 8. So the first 24 of the 32 are assigned to the network. So it says how many bits? Okay. So you need at least 2 networks. We've got to solve this problem. How many bits of the 8 that are available are we going to assign to the network? 1. We could do 1 or 2. Either one of those is going to be fine in this case. And then just hypothetically, if we gave 1 to the network, that would give us 7 left for host addresses. 2 to the power of 7 is 128, so that works fine. If we took 2 bits for the network, we could have 4 possible networks, 2 to the power of 2, leaving us with 6 bits for host addressing. 2 to the power of 6 is 64, so we could use that scheme as well. So depending on whether we did 1 or 2 bits for the network, we would get different answers here. And so I just kind of addressed that. Let us go to yes, Vaughn.
So, if you had to make that decision, would you do the 2 bits or the 1 bits?
Which one would I choose? You just love that answer. It depends. It depends on whether I thought I was going to, which thing I was going to run out of first. Do I think that I'm going to have more hosts than I originally intended? Then I would go with 1 bit for the network. If I thought I might need some more networks, then I might go with more networks. So depending on the situation that I'm in, I would make my choice that way. At a high level, especially as we're talking about AWS, you generally want to have as many networks and as many bits per network as possible, or as many hosts per network as possible. I know which doesn't really answer anything, but they actually give you have the option to be like really, really, really narrow and allocate just exactly what you need, but you don't want to do that. You don't want to allocate exactly 32 IP addresses if you think you need 32 IP addresses. There might be something later on where you're like, uh-oh, I need more in this network. So that's the only gotcha. Okay, as groups and as individuals, go ahead and solve this one. Same problem.
Yeah, so that shows you this slash 60 just coming in. No, sorry, you're right. Yeah. Okay. The slash shows you how many you have. 32 on 20. So just 8 bars. Yeah, because it's slash 8. Yeah, oh, okay. So there's a number, and then a 0 and a 0. So if it was number, because of the last, because the last 0 is inputs. So since there's 2 zeros, it's still 60. And there are 3 zeros, it's 24. So you get into where are you lost at? I was in the corporates. Okay, so do you see how many zeros are in the IP address? Each of those zeros times date is how many bits you have required. So we have 16, and it'll be this first 16 times
16 and we divide that first
base network, so 2 to however many bits.
so we have 200. So
2 to the 8. This is close. 2 to the 7. So we have 7 bits in the 8. So we have 2 to the 8. 256 networks. because we found, 2 of the 8 is like 256 networks. And so then does the other 8 just automatically go to our computers? So we don't have to figure out a smaller number.
So once you figure out the number of the networks,
Yeah, it just use the rest.
then you have to find the networks.
So is there a specified amount? So at this point, it's like, so the first 2 numbers are 60 bucks. 2 zeros are 60 bucks. So we ignore the first 60 numbers that are set out of the box. Within that, we can divide it. The first number is how many networks we have. Every single contributor but we never assign like phone addresses are to assign the first one. But we regularly just checking what the average address are. So then just the it's 2 to the
There's like a specified that's like
Yeah. If you get a low 3, So I'm curious to see how they're doing it. Okay. You need more time, or are you ready? Okay. If you are ready, how many bits are available for you to manipulate? 16. So there's 16 to the right of the network address. How many bits will you assign to the network? 8 or 9. Okay, 8 or 9. Okay. And why is 7, for example, not enough?
Not
128. Oh, right, 1, 2. Well, actually, wait.
Yeah, if you did 7, that would be 2 to the power 7, which is what number? 128 networks. Would that be enough? No, that would not be enough. Okay, so you do 2 to the power of 8, that gives you 256 networks. How many networks will there be? 256. How many bits are going to the hosts? 8. How many IP addresses will there be per network? 256. Does that meet our business requirements? Would you like to see a question like this on the exam? You can have one.
So we were discussing it. What if eventually you wanted 256? Would you need another IP address assigned to you, or how does that work?
You generally, if you plan wrong, you have to do a demolition. Think of it like a building, you know? If you have a room that only fits 75 people, what if you need, I don't know, 200 people? Well, you better knock out some walls. Same idea here. You got to start over again if you need more space. Yep. So that is why we plan. Okay. Yes, sir.
Why can't we use 7 for the host?
Why can't you? Well,
Like, I mean, it'd be wasteful, but as far as why always?
For now, there's other ways to look at things, but for now, let's not muddy the waters. We'll just say you dropped a line there. Everything to the left of that line that was assignable as your networks, and then automatically everything to the right of that line is hosts.
Okay.
We're not going to leave a gap in
Okay, so
between
there's
some
not gonna be
hanging
any-
bits.
okay.
For now, we'll just think of it that way.
So everything remaining will go to hosts.
Yeah, we'll just think of it that way for now.
Okay.
Okay, let's talk about subnet masks. So, when we're looking at, when we've been looking at these CIDR addresses like /16, /24, we've actually been looking at a subnet mask, the idea of a subnet mask. And let us see that in the wild. So first, I'll just show you this on on my Raspberry Pi. So if you were looking at your Raspberry Pi, Shift Control plus. Shift Control plus. Okay, so if I type in ifconfig and I look for my cabled connection, Ethernet 0, I see a line here that says Ethernet or iNet. There's my private IP address, and then I see two other things after it. We'll talk about broadcast in just a minute, but the next item here is net mask, 255.255.255.0. It just so happens that if I turn that into binary, how many ones would that be? 24. So really, this is just the exact same thing as saying this address /24. So it's right there. Similarly, if I were to RAM,
Why is it 255 instead of 256? Is there reserved or something?
because it starts at 0. Yeah. Oh no, it gets me all. That kind of stuff gets me too. It's like, wait a minute. Yep. All right, hold on. I'm gonna get Windows to open up here. All right. So if I open up something like PowerShell and I do. That's not awesome. All right, let's try that again. I was plugged in upstairs into other monitors, so it's VMware's trying to orient itself a little bit here. Actually, I like the other one better in terms of the resolution. Now it's going to be higher resolution, smaller stuff. But at any rate, if I open up something like PowerShell and I type in ipconfig, sadly, everything's going to be super small now. But if I'm going to do IP, well, actually that's kind of fine how it is. If I type in ipconfig, I see my IP address here. Stop, whatever you're doing. And then right underneath it, I see subnet mask. And again, I see 255.255.255.0. So that means with respect to the address above it, what is the CIDR notation for that? Again, this one is /24. And then, interestingly, if I go onto my Mac and so this is just my Mac's terminal. And if I type ifconfig on here, and lots of network adapters on here. If I find Ethernet 0 on this one, and I find this line that says, so this is my IP address for here at BYU in this room, 10.37.39.2. This one says net mask, and again, we'll ignore the broadcast for now. 0x, and then a bunch of F's and a bunch of zeros. And I had to stop and think about this for a second. What does that mean? This is the exact same thing. We could convert this again from hex to binary. This would end up being, so if an F is 4, ones, then we have 16 ones followed by the equivalent of 16 zeros. You follow me? Okay. So a minute ago we were seeing this as like 255s with regular numbers, base 10 numbers. Now we're seeing it in hex, so it's base 16. But again, bring it all back to binary, which is how computers think of things. So this basically we have 16 ones followed by 16 zeros, if we think about the binary there. So what is the CIDR notation with respect to this? It's /16. And so if we're thinking about that a little bit further, we're like, oh, so of this address, how many bits can be IP addresses? 16 bits worth, and then so 2 to the power 16 is 65,536. So, anyway, so you know where you're at, right? Just like the gospel, know who you are. Remember who you are. Now we know who we are, based on the fact we can read the subnet map. Okay, so with what I go over now, we're going to kind of re-emphasize all these ideas. It's going to be the same ideas, but a little bit different twist. So it might help you or it might hurt you. Okay, so I was going to ask you, like, what are all the things you can tell me? Well, I can ask you this right now. I won't even have to make you do it in a group. What are all the things you can tell me about this IP address right now, if I were to ask you questions about it? What? It's a private IP address. What else? You can tell me what it is in binary. And yes, I was thinking of that. Yeah?
So the network is 172.17.
It probably is. I'll say it probably is. That's a good guess. You don't know for sure yet, because we're missing that extra piece, which is our subnet mask. We don't know where the dividing point is necessarily. And then another thing that we could know is, based on our tables, we could know which class this is. Is it an A, B, or C? So we haven't talked about that a whole lot. In the early days of IP addressing, when we talked about classes of addresses, A, B, or C, so think of the classes as with respect to our private address spaces. So is it like below the 120? Well, I guess that's not a class. The way I usually think of it is, I know my local host address is 127, so below 127 I think of as my A addresses, and between there and the 172 I think of as my B addresses, and above that I think of as my C addresses. The significance of the different address classes is that you have, in the lower classes, you can have more hosts to assign in your subnetwork in the early days. Now things are more flexible, but that was the way we usually thought of them, is that the higher A, B, and C, or A and B had more addresses that you could assign out in your network than C. Okay, so I asked about what you know. But what do you know then if I give it to you this way? If I say this is the IP address again, and this is your subnet mask, now what do you know? Actually, talk about it in your group for a second. What's everything you know now?
Yeah, like 6, because each 0 is 8 bits, or each dot is 8 bits. So 16 private, 16 bits. It's 32 still. Because 8 plus 8 plus 8 plus 8. So each dot is an 8 bit. It's just the total. Yeah. So the first one is the IP address, the second is the subnet. So the subnet is how we figure out these things, I think. Yeah.
subnet based off of what they're doing. So they get 255, 0, 0, 0,
Yeah, Jake.
slash.
It's the zero, so the real slash.
Based off of
There's 16. Now, we have to talk about 16 networks.
We don't know because we don't know. So it's not split by the zeros, it's just, you just split it in half and 5. So even if you have 1 0 and you have 8, you can do 2 networks at 6 mediums.
Right. So it is the zero, Can the subnetting be like, can the subnetting be like 160, 100?
Because yesterday we were doing subnets from 10, 0, 0, 0, and
So one thing I should clarify is in terms of our table of classes, class B actually runs between 128 and like 191, and so it's after our typical 192.168 address that we get into the C's. So I need to correct that. It doesn't cut off at 172. It cuts off at 191.
Are we gonna have to know that?
Yeah. So I'll put it in the study guide just to make sure you know that. Okay. So I know that for some people there's a little bit of lack of clarity on this, and we're gonna hopefully make this more clear as we go forward. Okay. So I'm just gonna have you see things as I see them when I get asked this question. What is my thought process? This may be more helpful than just going through like an hour of theory about how all this works. Instead, I'll just show you this is exactly how I reason through the problem, and that's all you need if you can do the same. Okay, so when I see something like this, when I see an IP address like this, and I see a subnet mask like this, which happens to be the equivalent of /16, here are the things that I instantly know. I know, oh, it's a class B address. I know, oh, there's 65,536 IP address in the network range that includes that IP address.
Instantly know that?
Instantly now. I instantly know that the network address is 172.17.0.0, and I instantly know that there's 65,534 assignable IP addresses within the IP address range. So,
You are a god.
no. So, and I'll tell you in a little bit, I'm cheating a little bit, because whenever I see addresses that end with that are all 255s except for either the last 0 or 2 zeros, it's like the same thing. So that comes up so often that I'm just used to it. Where it gets tricky, and you're gonna have a homework assignment, is what happens if we have like some subdivision of this and it's not a 255. That's where it gets ugly. But like eating vegetables, parents used to say that'll put some hair on your chest. So my sisters didn't like that. But anyway, they didn't like that line. Anyway, it's good for you. But for now, we'll just go with the easy stuff. Okay, so Okay, so I'm just gonna kind of walk you through. Yeah, Cole?
Can you go back one? So why do we know that there are two less assignable?
I'm going to talk about that because 2 of them are reserved in every network. 2 addresses are reserved in every network. That's the short answer. So regardless of whether there's 256 or 128 or 16 addresses potentially possible, in the network, we always take away 2. And we'll talk about why in a little bit. Yeah, Evan?
But you can't tell from this how it's subnetted out, right?
Well, yeah, I can because I have this subnet mask right now. Right now it is divided based on the fact that it has that. So right now I'm assuming okay, like when I just did the IP config and the IF config, it's subnetted, it's done. It's cooked. We can't make it raw again. So when we get it that way, when we're looking at it on our local PC, that's what's already been done and subdivided. So right now I'm looking at this as if it's already subdivided because I have those 2 numbers. Okay, so I'm going to go through a process. Yeah, Peter.
If you were to have, like, these kinds of things on an exam, would you ask something ambiguous, like, tell me everything you can about this IP address, or would you say, what is this thing about this IP address?
Yeah, I'm going to ask, I'll give you like tables of information to fill out. You have a homework assignment that you're going to see where there's tables of information. All kinds of interesting things I can ask, like, what is this in binary? What is the CIDR representation of this?
Specific things, not, hey, list everything you can. Because like we might just forget to list something that we do know how to do.
Yeah. Okay, more hands. Let's go with Lindsay.
Yeah, when you said the network addresses and then the network broadcast addresses, do you always have just like 0 and then 255 or 76?
Oh. Yeah, sorry, I forgot to read that bullet point. I know it's 255. Frequently, it's going to be 255. Yes, and I'm going to show you my thought process if I were to go through this, like step by step, how I come to know every single one of these things. So it's not going to be magic. There's a thought process that you go that reveals every single one of these facts. So, and hopefully once you get them down, it's that fast for you too. Evan and then Guy.
Yeah, so just for clarity, you can't tell how many networks there are versus how many hosts, right? Subnetworks.
What do you think about that question? Do I know how many? At this point, based on what's been given, all I know is what the network address is here, and how many hosts are available in there. That's all I know at this information. Now it's possible that further up the food chain somebody was subdividing stuff, but we don't know anything else at this point. We don't know what happened before it got to here. How many times this address starting with 172 has been subdivided into networks. At the point that we get to here, this is all we know. All we know is our network.
Okay.
And this information also goes to your routers for directing traffic. It gets these two pieces of information. That's all it knows.
Okay, so if it was like BYU and it's been subnetted out to all the different buildings and everything,
Mhm.
and each one has its own subnetwork, and we had 16 bits to do that, and we decided let's give 4 bits for all these subnetworks,
Mhm.
that would be part of the subnet mask, right? You'd have like a number in that third octet that wasn't quite 255, because is that subnet ID part of the subnet mask, or not?
All right, so I'm going to answer it a little differently. So if I look at BYU's website, I think if I ping it, it comes back as 128 something. So, and there's examples of this in the chapter about exactly how they do this on college campuses. So you could also get a more perfect answer just by reading that section in the chapter. But just at a high level, they might say, BYU, you get 128 / let's say 8. So it means 24 bits, they can do whatever they want. But when I get onto the network in a room like this, it maybe comes up as 128 and then like some other subnet mask. What they've done is they've taken their networks that they had to work with and they subdivided them out around campus. Like, okay, maybe this building gets this network, and so it'll have some unique IP address and then a subnet mask. And every single, in theory then, every single college building could have a slightly different address and a subnet mask associated with it. So, I know it's probably not a perfect answer for you right now, but we don't need to answer that for what's coming up ahead. Okay, and hopefully your own question might get resolved as we go through this. Okay. Okay, so in terms of how I knew all this stuff. Okay.
Question.
Yep. Wait, sorry, this is like another set of, yeah, so I was going to do it for this as well. Yeah.
So in the previous
Gee.
slide, you said we only had 65,534 left.
Uh-huh.
Why is it 34, not 36, if you have 2 to the power?
So 65,536 is 2 to the power of 16. That's the total of potential IP addresses. But we reserve 2 of them, one for the network address and one for the broadcast address in every single network. So it's always the number of potential addresses minus 2. But we're gonna get to that in order, so I'm gonna repeat that. So just one step at a time. But if you want to know it now, you know it now. Did you have a question? Okay. Okay, so similar.
I'm so sorry.
Yeah.
That second number, is that the mask then?
Yes,
Or is
this
it
second number is the subnet mask.
Okay.
So it looks like an IP address, but the subnet mask only takes on particular values. It doesn't take on everything from in every byte spot. It doesn't take everything from 0 to 255. Because of the way we construct it, it only takes on certain values. So for example, you will see a 128, but you will never see a 129 as a subnet mask for certain reasons that will become clear later. Okay, so similar to the 172, yeah?
So with the subnet mask, we don't know what they've done with that last amount of bytes. We don't know how they've divided it. We just know.
At the point that we see it like this on our computer, we know that this number tells us exactly how many hosts are in our network at this point. So if you do ipconfig or ifconfig and you get 2 things like this, those 2 things tell you exactly in the network you're in how many computers you're communicating with or theoretically communicating with. But we don't. But the point it gets to you don't know what happened before then. You don't know how many networks there were and stuff like that. You just know, based on these numbers, how many computers are in your local network. Yeah, it doesn't seem like you're following, but that's okay. We're going to cover some stuff and hopefully it'll make it clear. Yeah?
So, potentially there is subnets within that, but we don't know because all we know is that that's the network portion.
That includes the
So-
network and the subnets, right?
Okay.
Sorry.
So I'll give you a practical example of what you guys are asking about. So with this address right here, this is 192.168.1. I could have another network that's 192.168.2 and another address that's 192.168.3. So higher up the food chain, I could potentially be incrementing these numbers to create whatever number of networks I needed. But by the time I get to here, I don't really know that. By the time it's on my local computer in a local office, I don't really know how it's subdivided, and I don't care. I'm the recipient. Right now we're talking about this as the recipient of the IP address, not the designer of the network. As the recipient of the IP address, we see what the designers did. We see that they locked us in to a situation where what this is going to mean is that there's 255 addresses in my local network, and hopefully we'll see why in a second. Callie.
I was going to say, I think one of the reasons why you should care is a fun story I learned from the network people.
Okay.
We at OIT. They had this problem where they had this small office, right? It was located near the Marriott Center, and so they gave it a small subnet that only had 255 people. They're like, that's going to be fine. There's nowhere there's going to be that many devices. It's a small office. Who cares? And then every Tuesday, their network would shuffle on and off. And they would always have devices that were constantly disconnecting. And they're like, why is this happening? Later they found out as people were walking to devotional, their phones were grabbing the IP addresses they went by and they'd fill up their 255 and then keep it locked down for about 15 minutes every time.
The leases have been given out for that time. Okay. Okay. Actually, how about we hold our questions, because I'm going to go through step by step all the ideas, and it might answer everything that you're asking. Yeah. Okay.
So it sounds like when you say there are so many networks, you mean like there are so many subnets, or there are 255 addresses in this subnet.
Yes.
Right.
Yes. This is yes. In short, this is telling this number, regardless of what the number is. In short, this number tells me how many addresses there are in my subnet currently. I don't know anything else above that. I don't know how many networks there are, but that is a short way to answer it. By the time I get this address, this subnet is going to tell me how many IP addresses are within my subnet currently, after some other designer designed it. Okay. Okay, so here's another number. So what do I know about this one instantly? I know that it's a Class C address. I know that there's 256 addresses, IP addresses in the network range that's been assigned. I know that the network address is this. And I know that the broadcast address is this. And I know that there's 254 IP addresses that can be assigned. So now I'll explain how I know those things at a glance for each of those two addresses with their subnet masks. Okay, so first, so I'm going to start off with the 192 Class C address first. First thing I know is that it's a Class C address. Why? Because I've supposedly memorized the table. So maybe that's in question now. Okay, step 2, we convert this. With our subnet masks, we convert them to binary before we move forward. We can't, unless it's a really common number, we can't really do anything in terms of understanding the IP addresses and the networks until we turn it to binary first. That's the trick. And it would be easy, it's tempting to avoid that, but you don't know it completely unless you go to binary. So I turn those two numbers into binary. Okay? Now, I do this thing called the logical AND. I multiply the two rows, and I create a third row. So wherever there's a 1 and a 1, it becomes a 1. Wherever there's a 0 and a 1, it becomes a 0. That's my logical AND. Okay. Okay, so I did this trick. So I turned those numbers into binary, and I multiplied them. And then remember last time I was talking about drawing that line? I draw the line wherever the ones from the subnet mask ran out.
What?
Okay. So I turn this number into a base 10 number again, back to a regular IP address. That is my network address. That's like saying I'm on Maple Street or Apple Street. Why couldn't you do it? Well, you can. You can if you're 100% confident in what you're doing. If you're 100% sure you're going to get it right. If there's the slightest possibility that you could get it wrong, and you'll see why you could get it wrong when you do the homework assignment, then you better go to binary and just look for where the ones run out. Yeah.
But as long as they're 255, you can just take them straight
As
down.
long as there's 255s, you can go straight down. I love me my 255s. Yeah.
So I'm just looking at our table, it's talking about Class C networks. And it looks like the 255, 4255, 4255 subnet masks are always paired with Class C. With the Class C network address. Is that right? Or is it possible that I have like a 16-bit subnet mask with that IP address? Or network?
We don't have to worry about the answer to that question. So you can kind of ignore the rest of what I'm about to say. My understanding is back in the original days that the subnet masks were fixed per address class. But we've become more fluid and flexible in the modern era, where we can kind of do whatever we want, is my understanding. But originally, that was the case.
So I guess I asked that because here, the ones in your second binary line really changed depending on the subnet mask. Like say it was a subnet mask of class B, then you would have to drop
A lot
you'd
of
have to-
stuff?
Yeah, like the line would be way more in the middle.
Yeah. I'm not gonna test you on anything related to that.
So they'll always match. So I guess.
Yeah, I won't, I'm just gonna test you on what I'm gonna show you, and then there's some other stuff that's out there to learn, so. But it is a fair question. Okay, let's go on to the next question. So we figured out our subnet mask, we figured out our network address. Our network address happened with everything that's on this bottom line. Now I wanna figure out my broadcast address. So our broadcast address is the equivalent of sending out, it's the equivalent of on the local area network where we do a broadcast of all ones to everything in the local area network, except now we're not just at layer 3, we're not restricted to just our physical network. At layer 3, we can send it to everything within a particular subnet, and that's critical. So that means we could be crossing switches. We could be going to everything within a particular subnet space, so that could be 65,000 addresses, 16 million addresses. That's why the broadcast address is important. So we're gonna create a broadcast address also based on this subnet mask. So, instead of turning everything into 0, I turn everything into 1 that's after that line, turn that into a number, that's my broadcast address. So, as an individual computer within a particular subnet, if you send out something to this address, it gets propagated to everybody in that subnet. Good and bad. Jocelyn, did you have a question?
Yeah, so for the line, you change everything to 1 and 0 based on the multiplication.
Mm-hmm.
But don't add those up for the first 3.
For the broadcast? So, okay, so step by step. First I turned both numbers into binary. Then I did a logical and this one right here became my network address. I'm just going to change all of those into 1s, and that's my broadcast address. So I've bounded it. This number right here happens to fall in between 1.0 and 1.255. All addresses are going to fall within a particular range defined by my subnet mask.
But what about the first 3?
These first 3 numbers?
Yeah.
Okay, those ones are staying fixed. So in this case, it's 192.168.1. So as we talked about the network address, those numbers are staying in place. And as we talk about the broadcast address, those 3 numbers are staying in place. The network address is then just going to relate to what comes after that. And the broadcast address is also going to relate to what comes after that.
So you actually don't need to change the first 3 bits.
Yeah, we don't need to change anything over here. At least at this point. There will be a harder homework assignment problem, but this is the basics. We're starting easy, and then we'll make it harder potentially. Yeah.
Network address and broadcast address are all reserved.
Yes, that's exactly right. What he said, Callan, we'll repeat it. Of our available range of possibilities, which here is 256, 2 to the 8, the 2 addresses that get taken away are the broadcast address and the network address. Everything else is assignable to hosts within a network. Okay, so I'm just going to repeat that right now. So to calculate the total number of available IP addresses within this network, I can take 2 to the 8, 2 to the number of bits that are there. So that could be 256 possible IP addresses. And then I know that 2 are reserved. And so I take 2 from that, and I get 254. Yes, Spencer.
So one of those reserved IP addresses is the broadcast.
That's correct.
What's the other one?
The network address. In these examples, the network addresses are always ending with 0s. And in these examples, all of our broadcast addresses are ending in 255s. That is not always the case, but for our easy examples right now, it sure makes the math really nice. So, okay, want to have a little break before we do this a second time? All right. Of course. Okay, this is our break.
I want to see if this is going to work. So go into the what's the URL?
We reset the iPad as a friend to turn on. Like on the